Hello everybody and welcome back. Today we're going to talk about the Maclaurin series, which is a Taylor series, and all the Maclaurin series is when you have an equation that is centered at 0, so a equals 0. That is literally all a Maclaurin series is. However, we do have some shortcuts to take rather than doing the Taylor series, so we're going to look at those today. Let's go ahead and do example. We're going to do number 13 from this section, which looks like f of x equals cosine x. All right, when a problem doesn't say what we're centered at, we assume that we are centered at 0. So let's start with our table. So we have f of n of x, and then f of n at a, which in this case is 0. All right, going down we have 0, 1, 2, and 3. And knowing how this problem goes, I'm just going to go through 4. And what this is f of x is the 0. This is f prime of x, f double prime of x, triple prime of x, and then the quad. Okay, so that's all the 0 through 1, so the nth term. So right here, we're always going to write the original problem, which in this case is cosine x. So how this table works is we go straight across. So we are going this way. So we go straight across cosine. And instead of saying x, we put in what our a is, which in this case is 0. So the cosine of 0, which is 1. So moving down, every time we go down to the new one, we are taking the derivative, so f prime of x now. So we'll have a negative sign of x, and this will give us a negative sign of 0, which in this case is just 0. Keep taking the derivative all the way down, so we'll continue. The derivative of sine x is a negative cosine x. This will give us a negative cosine of 0 still, which is a negative 1. Continuing down, negative cosine, the derivative of that would give us a positive sine, x. So then sine of 0 is still 0. And then one more, the derivative of sine x would be a positive cosine x. And then we have cosine of 0 will give us 1. So this is how that table works. Now all we're going to do is plug into our given equation, which is always going to look like this with the Maclaurin series. We're going to start with f of 0. You're going to add the prime of f of 0. Continue adding on, but once you hit the third term, it's double prime of 0 all over 2 factorial x squared. And this will continue on, so triple prime. Now we're going to have x cubed all over 3 factorial. So if you notice, our exponent is always going to match our factorial in the denominator. Okay, so knowing that this is what we plug into for any Maclaurin series, let's go ahead and plug in our numbers. So we know that f at 0, let's switch colors here, f at 0 in this case is 1. So that will be our first term. So that is that term. Then we're going to add on our next term. F prime at 0 is right here, so we're going straight across f prime, and then you can see it right here. So if you do get confused on what you're actually plugging in from the table, just go find the term you're actually looking for. So f prime was this one. F prime at 0 is 0. That's that term. Adding on, so now we have double prime. Our double prime in this case was a negative 1, so parenthesis, I'm going to say a negative 1. And then this is multiplied by x squared all over 2 factorial. Continuing to triple prime, so we have a 0, so plus 0. And these are just going straight down. Dropping to a second line here, let's go ahead and add on our next term. So our quad in this case is 1. So I have 1 times, in this case would be x to the 4th, all over 4 factorial. Okay, we can simplify this just a little bit. So let's go ahead and do that. So this will give us 1, and if you notice we skip each term, I'm going to add in this negative out front, and this 2. So we have 1, skip the 0, minus, with that negative, x squared, 2 factorial. And then this will continue on, and this is an alternating sequence, so that helps us a little bit. So then we have plus x to the 4th power all over 4 factorial, and you can imagine how this will go. So then it'll go minus x to the 6th, 6 factorial, plus x to the 8th, 8th factorial. And that's why you don't want to do too many places on your chart and on your table, because you will find patterns throughout all of these. Now we are not quite done. We have one last step as simplifying. So our final answer will be 1 minus x squared all over 2, which is 2 factorial. 2 times 1 is 2. Add on our next term, x to the 4th. 4 factorial will be 4 times 3 times 2 times 1. So you'll just continue this throughout the entire problem. So I hope this helps visualizing how to set up this problem. Just go ahead and plug in what you know from your table. You go straight across your table, left to right, plug into our given equation, which is up at the top in green, and that is the Maclaurin series.